find partial differential equation. Yesterday I did not discuss partial differential equation. So what do you mean? Please repeat it.
No, sir. That M and N in one question you did that not
Sir,
dn
Okay,
by
okay.
integrated
So
dx.
that is
differential.
to check the exact whether the differential equation, given differential equation of the form
Is I
mdx
was
plus
Sir,
asking
can
n.
you?
about it, whether how it is derived or
Acha, so derivation,
the
derivation.
correlation with Green's theorem or not.
Uh,
Sir, can you
Green's
repeat that
theorem,
part? I cannot get
you
it.
need some boundary, so close boundary within that region. So you can always connect, but this is more general. Okay.
Sir, can you repeat that part? I cannot get that thing properly.
Exactness.
Yes, sir.
Okay. So yeah. So a differential equation of the form m dx plus n dy. So yeah, this one m dx plus n dy is equal to 0 is said to be exact differential equation if it can
No,
be
sir, not that thing. But that differentials you have calculated, what is the significance of that? I'm asking that thing.
Achha, this will just guarantee that you mean physical significance.
Yes, sir.
Physical significance, it is at this stage it is difficult to mention. This is just mathematical condition by which you can represent this differential equation in this form. du is equal to 0, where u is some function of x and y. Okay, so this is a mathematical condition. Okay.
Okay, sir. Got it.
So as I mentioned earlier that there are several conditions to make a differential equation which is not exact uh, by multiplying it with some appropriate factor which is called integrating factor. And there are several methods depending on the nature of the functions m and n. So I'm not going into that detail of those methods, which is not necessary at this stage. But all the problems involved later you will see can be solved, or the relevant integrating factor can be derived by if we just use these differential relations. Okay, I already discussed a couple of problems, and today, if I get time, I will discuss more. Okay, so next, after that, we discuss ordinary differential equation of first order but of higher degree. First order but of higher degree. A general first order ordinary differential equation of degree n can be represented in this form. P to the power n, P to the power n means dy dx whole to the power n. P is dy dx. And this has been written in polynomial form in terms of the first order derivative dy dx. And first category of the differential equation we can handle under this type of differential equation is the equation which is solvable for p. That means we can express equation number 4 as a factor, as a number of factors. Okay, so of the form p minus f1 xy into p minus f2 xy, so on p minus fn xy equal to 0. And then what we will do, we will consider the individual factors. We'll consider the individual factors and then we form the first order differential equations given by p minus fi xy equal to 0. Okay, we will solve all the equations. So we have n number of equations at most in that case, and we will solve. And solving the equations, we will get different solutions, and then we can write the general solution in this form: g1 xyc, g2 xyc, and gn xyc equal to 0. Okay, so one of you asked an interesting question, that why we are taking this type of solution. Okay, so let me just explain a little bit why we can do this. So what is the original differential equation? That can be represented in the form f1xy p minus f2xy so on p minus fnxy equal to 0. So many are joining using Gmail. Okay, in the next class, always use your institute email. Then directly you can join. Okay. Okay, so now what we are doing, we are solving all the equations given by the individual factors. So I can write I is equal to 1, 2, up to n. And we are getting the solutions of the form, say G1, X, Y, C1 equal to 0, G2, X, Y, C2 equal to 0, so on, Gn, X, Y, Cn equal to 0. Now we know that, although we have not formally proved it, that for a first order ordinary differential equation, always there will be only one arbitrary constant. We cannot have n number of arbitrary constants. Okay, we can prove it.
So can you repeat again?
For a first order ordinary differential equation, the solution, general solution, will involve only one arbitrary constant. There cannot be, say, C1, C2, and Cn, n number of arbitrary constants. So therefore,
Okay, sir.
as these are the solutions for the
So
arbitrary
the
constant,
reason behind this is, so why this happens?
so that proof I have not included. We have not included. So if you are interested, I can discuss it separately. Okay.
Okay.
At this moment, please assume. But one can prove this, that a first order differential equation, the solution of a first order differential equation, a general solution of a first order ordinary differential equation will all involve only one arbitrary constant. So therefore, what we do, we write C1 is equal to C2 is equal to Cn equal to C, and take the solution in the form XYC G2 XYC so on Gn x y c equal to 0. Now why we are taking this type of solution? Now what is the meaning of solution? This is implicit solution, clearly implicit solution. What is the meaning of solution? That this is basically a relation between the independent and dependent variables which will satisfy the differential equation 1. Okay, so from this relation what we can do, either we have this yc equal to 0, G2 x y c equal to 0, so on Gn x y c equal to 0. Now from these individual functions, we can, if we differentiate it, we can show that this is equal to 0. If we differentiate this algebraic relation, we can derive this equation. And if we do the same exercise for other functions, we will get p minus f2 xy equal to 0, because this is a solution of this differential equation. Therefore, it will satisfy this one, so on. Okay, so p minus fn xy equal to 0. Okay, so all these algebraic equations are satisfying this differential equation. Now you simply multiply and get this differential equation. So therefore, what we can get, that these algebraic relations are satisfying this differential equation. Therefore, one can write the solution in this form, and it involves only one arbitrary constant. Therefore, it is a general solution of the first order ordinary differential equation. Okay. Next, so problem number 1 and 2 I have discussed, I think, in the last class.
Yes, sir.
Okay, so problem number 3, can you try? X square into p square minus y square plus y square equal to
Done, sir.
Huh? You have already done.
Yes,
Okay.
sir.
Okay. Let me show you. X square into p square minus y square plus y square. P square minus y square plus y square, and this is equal to x to the power 4 plus 2xyp. X to the power 4 plus 2xy. Now, if we just p square minus x square, we can write it in this form: plus y square minus 2xyp minus x to the power 4 equal to 0. This implies we can take these three terms and we can write at y minus px whole square, and the other terms we can put in the right hand side and write in this form: x square plus y square. Okay, so therefore we have y minus px equal to plus minus x root over x square plus y square. So that means what are the factors? Y minus px
Divide.
equal to x root over 1 plus x square plus y square. Let me do it simultaneously. Okay, so therefore what is your p? P is equal to
Divide.
minus y by x plus minus
root over
is there any problem?
Sir, y by x, not minus sign will y minus
Only
sign will
y
not.
by x.
Yes.
yes sir, only y by
Equal to p equal to y by x
Plus minus under root x square plus y square.
So
um,
plus minus.
Acha, this is this.
yes sir, minus plus
Yes, sir.
Okay, so that does not matter in this case. X square plus y square. Acha, x to the power 4 was there, and px minus y if we write
Correct, sir.
by x.
Sir,
No, sir. Correct, sir.
Then how we can solve it? We have to solve both the
Sir,
equations.
sir,
Yes.
we can take under root x square plus y square left side. Then we can solve easily.
Yes, sir. Y is equal to Vx, sir. Let.
Acha, so
Yes,
let me.
Sir, homogeneous equation.
Yes, sir. P is equal to divide by dx.
No, it is not homogeneous actually.
Sir, we can take under root x square plus y square left side.
Yes, sir.
Then we can
Let y is equal to Vx.
Sir, yes, sir, it can
Sir,
become
in root,
take x square common from the root, it will become 1
Yes,
plus
sir. 1
y
plus
by
y by
x.
x to whole square, sir.
तो सर वो y by x टर्म आ रहा है मतलब सब
yes, sir.
Yes, sir.
लास्ट में
Acha, so did I? Yes. In the second step, is there any problem?
No,
नहीं,
Sir,
Second
no,
step.
sir, no, sir, no, sir.
solution is okay, sir. Final equation is fine.
Yes, sir.
Sir,
Final
last to
equation.
second.
So then how we can solve it?
Sir, from last to second step, take under root x square plus y square left side and change it in the form of y by x.
yes sir.
Here.
Yes, sir.
Yes, sir.
Okay. Okay.
yes, sir.
This is equal to.
So then take y equal to vx, then only it will be
X
Uh-huh,
square
very
common,
good.
sir.
So we can take x square into 1 plus y by x whole square half. X we can take common, and then
Sir.
what?
Yes, no, sir.
Sir, y minus px by x square can be changed into d of y by x.
Yes, sir. dy by dx is equal to y by x plus under root x.
Just a minute.
Sir, it is not a perfect homogeneous form.
This is not the homogeneous equation. That is the thing, because the degree of each
It
term.
will
But
not
sir, it
become
will be easy
homogeneous.
by taking
Whatever
y
we
equal
do.
to bx.
Yes, sir.
Y
Sir,
equal
it
to
will be
Vx.
homogeneous
Yes,
only,
sir.
sir.
No, no,
Yes, sir.
we
Because
cannot
here
take y
we
is
get
equals to Vx.
y by x
Are
from
we can take
both
it is
sides.
being solved. Answer also
No,
A
sir.
and B.
Yes, sir.
Actually, we can
Just a minute. Achha,
take
some
from
more.
y by x square is equal to z, and then
Okay, so anyway, you can try to solve it and then tell me the result. You just solve it and tell me the result. So 2 minutes I am giving you.
Log y by x plus
Log y by x, just a
plus
minute.
under root x square plus y square by x. Minus x minus c into.
Achha, so y equal to Vx, I think it will work. You can try it.
Yes, sir.
Yes,
Yes,
sir.
sir.
Y equal to Vx, I think it will work. Because you will
Yes, sir.
get
We have to make the under root in the form of y by
Yes,
x.
sir.
mhm.
Under root
So
1 plus y by x square.
so you can solve it actually. You will get something like this. P is equal to P will become V plus x dv
X dv by dv. X dv by
dv by
dx.
dx, and
X
this
dv
one will
dx.
be V plus minus root over x
Sir,
into
V
root
plus
over 1
X
plus v
into.
square.
V plus
Yes,
dx
sir.
plus.
Yes, sir.
Yes, sir.
That will.
So now
So
we
this one is cancelled. This
Yes,
one
sir.
is cancelled. Now it is easy.
X also,
Yes, sir.
sir.
Okay.
X
So
also
x
cancel.
also can be cancelled.
Yeah, x also is cancelled,
Yes, sir. Very easy,
and
sir.
then it is easy. This
Yes,
is
sir.
easy.
Yes, sir.
dv by root over 1 plus
1
v
plus v
square
square
equal to plus
equal to
minus
dx.
dx. So now you integrate and find both the solutions and then write the general solution. Okay. Next,
But sir, we can do this only if it is homogeneous.
no, not necessarily. For homogeneous, it will definitely work. But in some other cases also, it might work, the substitution y equal to vx. This
Here
is
we
the,
get form of y by x, so we use y equal to bx.
yeah, it is not, although it is not homogeneous, because first term has the degree 0, but second term has degree 1. Second, yeah. Still it worked, this substitution. And for homogeneous, it will definitely work. And next question number 5.
Yes, sir.
Yeah, e to the power x, and 1 you can represent as e to the power x into e to the power minus x. Then you can factorize it easily. So we have this p square minus e to the power x plus e to the power minus x, p plus 1 and equal to 0, and this equation can be written as p square
1
minus
equal to e to the power x into e to the power minus.
plus e to the power minus x into p plus this thing we can write it as e to the power minus x equal to 0. So now you will get this is equal to p minus e to the power minus x. Now you consider all the factors and solve it. So if you consider the first factor and form the differential equation, this dy dx is equal to e to the power x. So this implies y is equal to e to the power x plus c1. And if we consider the second factor,
Y
e to the
equal
power
to minus e to the power.
Minus
equal to 0, e to the, so dy is equal to e to the power minus x dx. So upon integration, we'll get this, and y is equal to minus e to the power x plus c2.
So minus.
Minus x, yeah. And what is the general solution then? Y minus e to the power x and minus c
Y
into y plus e to the power minus x minus c This is the general solution. So we'll not take two separate arbitrary constants. Okay. Well, so I think all of you. Yes. So what did
So why
you
not
ask?
separate? So why not separate constant?
Yes, sir.
Achha, so this is a first order partial ordinary differential equation. Its general solution cannot have more than one arbitrary constant. So that theorem that result I have not proved. I have just used this. Okay, so at this moment, if you are interested and if I get time, I can discuss this in a separate class. Okay,
Sir,
but at this moment, you have to you use this result. Yes.
Sir,
sir,
in this question we get factorize it, but what if we don't get factor of the equation?
And then we have to look for other methods. This method will
Yes, sir.
not work.
Sir, quadratic in P, sir. Minus B plus minus under root B square minus 4C by 2.
So if you cannot factorize, okay, quadratic equations can be much more complex.
It's
It may
not
not be
about
possible.
quadratic. So what if it is a cubic or a quadratic?
Yes, yes. So in many cases, you will not be able to solve it. Then there are other methods which I will discuss shortly.
yes, sir. For
We have to explore those methods. Okay. So if you can factorize, then this method will work. Well, so now we have already discussed that if the given differential equation is solvable for P, how to solve it, we know. Now, if the equation is solvable for Y, that means we can write Y is equal to some function of X and P. Y is equal to f of X and P. So you can write the differential equation, express the differential equation in this form. That means it is solvable for Y. Then how we will proceed? We will just differentiate both sides with respect to X. Achha, in the left hand side we will get P. There is a mistake. It will not be Y. 7 is differentiated with respect to P. With respect to X. So this will not be Y. In fact, this will be P. So we will get this. So therefore, now in equation 8, you see only P and dP dx. P and X are involved. XP dP dx is involved. And then if we solve, if this equation number 8 is solvable, we will get an equation of this form involving X, P and C. Okay. So now if we eliminate P, in a solution P cannot be there. If we eliminate P between 9 and 7, we will get the general solution of the given differential equation 7. So let me discuss the method once again. If we are able to solve the differential equation in terms of Y, that means we can write Y as a function of X and P. P is the derivative of Y with respect to X. Then what we will do, we will differentiate 7 with respect to X. In the left hand side, we will get P, and which is equal to G, some function of X, P and dP dx, because in the right hand side, we have X and P. In the terms where we have X only, that will produce X or X, and the term which has P, it will produce P and dP dx, as we are differentiating 7 with respect to X. Now, this equation number 8, I will demonstrate it using the particular examples. If we solve it solve the equation number 8, we will get an equation of this form. Now, this equation number 9, it involves P, C and X. So, this P we have to eliminate from 7 and 9. Then we will get the general solution. Is the method.
So how from equation 7 we get this equation psi in terms of psi?
Okay, so let me discuss in terms of example. Let us consider this example. Equation number 1. So differential equation y is equal to here y plus px x to the power 4 p square. Okay. The equation is y plus px equal to x to the power 4 p square. This is the differential equation. Now you see this can be expressed as minus px plus x to the power 4 p square. So that means we could express y in terms of x and p. This is your f xp, function of x and p. Okay, function of x and p. Function of x and p. Now what we will do, we will differentiate this with respect to x. So dy dx in the left hand side we will get, and in the right hand side minus p minus x dp dx plus 4x cube p square 4x cube p square plus 2x to the power 4p dp dx. And this left hand side is equal to p. P is equal to minus p minus x dp dx plus 4x cube p square plus 2x to the power 4p dp dx. Okay. So therefore, what do we get? 2p plus x dp dx. And if you take 2 x cube p, you will get 2p plus x dp dx. This is equal to 0. So this is my equation number. This is my equation number 8. Okay, so this is my equation number 8. This is equation number 8. Now you can solve it for p. So 2p plus x dp dx, we can take common, and we will get 1 minus 2x square x cube p. This is equal to 0. Okay, so therefore either 2p plus x, therefore either 2p plus x dp dx, this is equal to 0, or 1 minus 2x cube p, both factors are equated to 0. Now from this first factor, you can solve for p, and you will get the equation number 9. You look at the theory, this one. Some function of x, p, c you will get. You solve it, so dx by x plus 2p, dp by 2. So we can take 2. We can take a 2 over here, and dp by p equal to 0. So if we integrate this, what we will get? X square
equal to minus
p, x square p equal to c. You can adjust the arbitrary constant c in this fashion. Okay, so this is my equation number 9. Equation number 9, which is a function of x, p, and c, the arbitrary constant. X square p equal to c. Now we will eliminate p from this equation and the original differential equation. This is equal to p c by x square. Okay, so therefore in the original differential equation, so what was that? Here y plus px is equal to x to the power 4 plus x to the power 4p square. So here we will substitute. So y plus px equal to x to the power 4p square. So if we eliminate p from these two equations, so what we will get? We'll get c by x square into x. This is equal to x to the power 4 into c square by x to the power 4. This is cancelled, and One x is also cancelled. Therefore, this will imply y plus c by x equal to c square. So, which is a general solution? This is the general solution. General solution of the differential equation. Now, you see, while solving, we have another factor which can also be equal to 0. 1 minus 2x square p equal to 0. So, from this, if we use this factor, then we will get p is equal to 1 by 2x cube. Now, if we eliminate p from this equation and the original differential equation number 1, so we'll get another equation which will satisfy the differential equation. That means control Z x into 1 by 2x cube, and this is equal to x to the power 4 into 1 by 4x to the power 6. That means what you will get? You will get x square, and here also you will get x square. So that means y plus 1 by 4x square, this is equal to 0. That means 4x square y plus 1 equal to 0. Now this is a solution of the differential equation. It will satisfy the differential equation. This is a solution of the differential equation which does not involve any arbitrary constant, and it cannot be derived from the general solution. You see, for any particular value of c, this equation cannot be, this solution cannot be derived. And such a solution which does not involve any arbitrary constant, yet it satisfies the differential equation, and it cannot be derived from the general solution by, for a particular value of the arbitrary constant, is called a singular solution. The name of this solution, this is called singular solution. So later, in many differential equations, apart from the general solution, a singular solution will come. So we will discuss that. Okay, so is the method clear to you?
Sir,
If
can
the
you
equation
repeat
is
Yes, sir.
Show the previous slide, sir.
so, here we could express y in terms of x and p. It is solvable for y. And then we just differentiated with respect to x and factorize the resulting equation involving p and x, and then we considered individual factors and got general solution as well as singular solution. Okay, so I repeat, singular solution is a solution of the differential equation which cannot be derived from the general solution number 1, and it does not involve any arbitrary constant.
Sir, can you repeat the next slide?
This one.
Yes, sir.
So this is your general solution, this one, and this one is singular solution. Okay, so now you consider the next problem, problem number 2. Y is equal to, it is already given in terms of y. Y is equal to a function of p. Y is equal to p tan x plus log cos p.
10p or 10x?
Tan p. P tan p.
P.
P, yes. Can you see this now? Y
Yes,
is
sir.
equal to p tan p plus log cos p.
There is no x in the solution.
Yeah, it is not x in the differential equation. This is not the solution.
Yes, sir. Yes, sir.
There is no x in the differential equation. Still, we can consider it as a function of x and p. where is this? Yeah. Y is equal to P tan P plus log cos P. So let us solve
Sir,
this equation.
in the previous question,
Uh,
we get the singular solution by putting some value of C in the general solution. We can
just
get that singular solution.
a minute. So what is your point? Can you
Sir, in the general solution, if we put some value of C,
yes?
can we get the singular solution?
No. If it can be obtained, then it is called a particular solution, not a singular solution. For example, if we put C is equal to 0, you will get Y is equal to 0, right? Y equal to 0 is a
Yes,
particular
sir.
solution of the problem, not a singular solution. And if we put, say, C equal to 1, that is also a solution of the differential equation. Then Y plus 1 by X is equal to 1, it is a particular solution. But this solution, 4x square Y plus 1 equal to 0, cannot be obtained by putting specific values of C, and
Okay,
it
sir.
does not involve any arbitrary constant. So therefore, it is a singular
Okay,
solution.
okay, sir. Got it.
Sir,
Yes.
sir, here P equal to 1 by 2x cube.
Here, in this problem, are you talking about?
No, sir, the previous one.
Previous one. Okay. This one.
Sir, after that, what you did? P equal to 1 by 2x cube. Then
Sir,
y.
done. Solved.
This one. So we consider the next factor. Okay. So first factor gave us the general solution. And then there was another factor, 1 minus 2x cube P. And from that factor, we obtained P is equal to 1 by 2x cube. So you look at the factors, this one and this one. This factor gave us the general solution, and the other factor gave us the particular solution by involving the original differential equation. Okay.
And then, sir, after P equal to 1 by 2x cube, what you did, sir?
So I have just eliminated P from the
Put the
equation number
value
1.
in the
Put the value of P,
equation.
or the P is equal to 1 by 2x square in equation number 1 to eliminate P. Okay. And then we got. Yeah. And in the next case, let us once again, it is solvable for P, solvable for Y. So therefore, what we will do, we will differentiate both sides with respect to X. In the left hand side, we get this P sec square P dp dx plus 10p dp dx minus 10p dp dx. So this is cancelled. And then we get
Yes.
1 minus sec square p dp dx equal to 0. So we have two factors. One is p equal to 0, and the other one is 1 minus 1 minus sec square p dp dx. This is equal to 0. So therefore, what do we get from here? Dx minus sec square p dp. This is equal to 0. On integration, we will get x minus 10p plus c equal to 0. From here, we'll get this. And then we will get 10p equal to x plus c. And therefore, p is equal to 10 inverse x plus c. Okay, and this you can use here to eliminate p from the equation this. And if we put p equal to 0, what we will get? And we'll get another solution.
Y equal to 0.
Yes, sir.
This is a singular solution. Whether this is a singular solution or not, let us look at the general solution, and then we will
No,
comment
sir,
on
it
this.
is not singular. It will
Okay,
not be.
so then it cannot, it should be obtained by putting specific values of C. Okay, so let's see. So let us write the general solution. Y is equal to P is equal to tan inverse
Tan inverse x plus c
x plus c, and this
into
is
x plus c.
no into tan P was there. What is your tan P? Tan P is equal to x plus c.
X plus c.
Okay, so better to write x plus c, and then we have log
Minus 1 by 2 into log of
Log of cos tan inverse
1 plus x
log
plus c
cos
Log
P.
of 1 by log of 1 by root over x plus c
1
square
plus x
plus
plus
1
yes sir
Yes, sir. 1 minus
x plus c
1 minus.
whole square.
x
Sir,
p
1
X
plus
plus
square.
c
square plus 1
square plus 1
1 minus
plus
x plus p whole square. Yes, sir. Under root.
plus 1, not
Okay, so
minus.
now
Plus, sir, 1
plus
plus.
sir
plus
1
this
plus
one, this one.
Oh,
Yes,
yes, yes, sorry.
yes
Plus
sir
1.
for c equals to minus
Okay,
x y equals to 0
for P equal to
minus
C
x
equal to
minus x
no minus x we cannot take. It is an arbitrary constant. X is a variable.
so c equals to 0, x equals to 0.
No, x equal to 0 you cannot take. You have to take specific values of C only. Okay, and then if you can derive the other solution, then it will be a particular solution. Otherwise, it will be a singular solution. So, is there
That will be a
any
singular
specific
solution.
value of C?
c equals to minus
No
x
sir, no sir.
Sir, no, sir. X plus c can be belongs to minus infinity to infinity. Tan inverse.
So, therefore, a y equal to 0 is a singular solution. Let's see. It is a singular solution. Singular.
please again explain the reason why we can't take c equals to minus x
C is an arbitrary constant. Okay, you have to take the real numbers.
It's not a variable.
X is the variable. You cannot put x is equal to some variable. It is some constant. Okay. You cannot take c is equal to variable, some variable. Okay, so that can be done in case of partial differential equations where arbitrary functions appear. Arbitrary functions appear in the solution. Okay, you will learn it in the next semester. Well, so this is done, and then next what we have, if it is solvable for x, solvable for p we have done, solvable for y we have done. Now if it is solvable for x, then once again what we have to do, instead of differentiating with respect to x, we have to differentiate it with respect to y, and you will get this in the left hand side. You will get dx dy. Dx dy, which is equal to 1 by p, and it is a function of y and p then. And then once again we will solve it to get a solution of this form, which will involve p and c, and from equation number 12 and 10 we will eliminate p to get the general solution. And if there is some additional factor, it might also give a singular solution. Okay, so let me demonstrate the method and then you will understand. So this is the equation. Let us consider the example number 1. A y p square plus 2x minus bp minus y is equal to 0. A is a number which is greater than 0. It is a positive real number, and b can be any real number. B is also a constant, but it can be positive and negative, but A is positive. Okay, so you write it down and then tell me a y p square, the given differential equation a y p square. Then what is the equation? Tell me.
2x minus b into p.
Plus.
Yes, sir. Plus 2x minus b into p.
B into p.
Minus y is equal to 0.
Minus, no, there must be some a. Acha, minus y equal to 0. Okay. Yes. Y equal to 0. Now you see, it is solvable for x. You can check it. 2x minus b, this is equal to y minus ay p square. And this implies 2x minus b is equal to y by p minus ayp, one p is cancelled. So this implies 2x is equal to y by p minus ayp plus b. So therefore, we could express x in terms of y and p. Okay, so this implies if we differentiate this with respect to y. With respect to y, both sides, then we'll get 2 by p. So this is dx dy is equal to 1 by p. And here 1 by p minus y by p square dx dp dy, sorry, dp dy minus a p minus ay dp dy. Well, so this will imply 1 by p plus ap plus, let us bring everything in the left hand side, y by p square dp dy plus ay dp dy, this is equal to 0. Then so what we can do?
Sir, take 1 by p and
Y
y
common, sir.
that common. First and third term. And take common
1 by p.
Yes, sir.
yes,
And
sir.
1 by
Yes.
p square
1 by
from
p
there.
common from first and third term.
Then we'll get
1 plus
1 plus a p square.
y by p dp dy.
1 plus ap square plus dp dy,
1 by p square from here.
and then dp dy y by p square.
Y by p square.
Achha, if I take p common, then what will get?
Yes, sir, it will come, sir.
If I take p common, then we will get 1 by p square plus a. And then if we take y dp dy common, we will get 1 by p
So y by
square
p
plus
square. So y by p square. So y by p square dp by dy.
no, I am taking common y dp dy common.
No, sir, it's correct only, sir. Correct.
This is correct, I think.
Yes, sir.
And then we can take common. This will imply y dp dy plus what? Plus p. Plus p. This is equal. This is one factor. Then 1 by p square plus a. That is another factor. Now the second factor cannot be 0. You see, 1 by p square, it is square number, and a is given to be positive. So therefore, this is greater than a basically, and so we can write dp dy plus p equal to 0. So now dp by p plus dy by y equal to 0. And this implies py equal to c. This is my equation, and the second factor will not give you anything, so there is no singular solution in the problem. P is equal to c by y. We will substitute this in the given differential equation and get the solution. This ayp square. So therefore, eliminating p between this, ayp square means c square by y square. Then we have 2x minus b plus 2x minus b into p, that is c by y minus y.
Yes, sir.
So you simplify it and you can write the general solution. You will get the general solution, and there is no singular solution of the problem. Well, so now you solve problem number 2. It looks very simple, and find the general solution as well as singular solution for the problem 2. X plus p by root over
Sir, we have another class.
1. Oh, I have another class. Okay, so then tomorrow, so hopefully there was no problem in today's class. Was there any problem?
Sir,
No,
please
sir.
show the last question
No, sir.
solution.
No problem.
So
Sir,
should I continue with these teams?
Sir, why we are adding the
Yes,
two
sir.
solutions? The multiplying, sir.
Which one?
Sir, means
Which one?
first method of solution, na, sir, of solving higher degree. First method.
Which are solvable for p? Factorize.
No, sir. Means we are, yes, sir.
Yeah, as I explained in the first slide that if you consider the
First order, there will be only one auxiliary constant.
so you are you talking about this method?
Yes, sir. Yes, sir. Why we are not adding?
Why we are? What is your question?
Not adding, sir, different solutions.
Achha, if we add, then
there
you
will be
cannot.
more than
Then
one
also
auxiliary
we
constant.
will get the one constant, sir.
No. If you add, you will not be able. It will not satisfy this differential equation. It may satisfy a particular term of this differential equation, but it will not satisfy the product form. You think about that. I just mentioned that this will give us, if we take the solution in this form, g1 into g1 xyc, g2 xyc, so on, gn xyc equal to 0, then either g1 xyc equal to 0, from that you will get the first part, p minus f1, if you differentiate it, you will get the first part, p minus f1 xy equal to 0. But if you take the addition, you cannot take g1 xy c equal to 0 to take the addition. There you will have the difficulty, and as a result.
Sir, please show the last problem once again.
Okay, so
Okay, sir. I got it.
Sir, you show the last problem. You think about it. I hope you will understand what I am telling. This one.
So for which type of differential equation we will use partial differentiation?
It's the solution of first part. Solution of first part. Can you show?
Achha, this one.
And sir, upload the notes also, sir. Means
Sir, for this 1 by p square plus a, you told something. I lost my connection. Please explain.
Achha, 1 by p square is positive and p equal to 0. If p equal to 0, it is undefined. So we will not consider that. So otherwise p is non-zero. For p is non-zero, it is this equation is valid. And now 1 by p square is positive and a is given to be positive. So therefore, this factor 1 by p square plus a cannot be equated to 0. Okay,
Sir,
because
why
this
p
is
should be
always
positive? It is dy by dx. It can be negative.
positive, negative. That is fine. But 1 by p square is always positive.
Always
Square.
positive.
Yeah, and p equal to 0 case we have to ignore from the domain. So we have to exclude the points from the domain where p is equal to 0. Otherwise, this part will be undefined. This 1 by p square. Okay. And a is given to be positive. So sum of two positive numbers is positive. Therefore, this factor you can remove. Okay. A b equal to 0. If b is not equal to 0, then a must be equal to 0. That is the way. Y dp dy plus p equal to 0. And then we proceeded and found this. And next we eliminate p from this and the original equation to get the general solution.
So we get a general solution.
Yeah.
Sir, so the last question. And sir,
This one?
uploads the notes also.
Yes, sir. So
Okay,
here P is dy by dx.
Sir, please upload this PPT.
Yeah, p is equal to dy dx. Yeah, that is standard actually. Okay, it is used in the literature. Okay.
Okay,
P
sir.
is equal to dy dx.
For which type of differential equation will use this?
Acha, so there is one book where you will get many problems. So let me just write it down. If possible, you can have a copy of it. It is not costly. Differential equations. Differential equations. Chakra, Bharti, and Bose. So cost is around 200, 250. If you can afford, you can just have a copy of it.
Sir,
And
please upload notes, sir.
Will the PDF be available in?
PDF, I think not available. Okay. And yeah, you can see. Otherwise, I will provide you the problems after we complete all the theoretical part. We will supply you the additional problems, and then I think your preparation will be reasonable, so that you can
Sir,
handle.
sir, if possible, can you provide the problems early? Because by the time we finish, we don't think we will have much time left. Since the
Yes, sir.
Okay, so then this
short-
weekend I will provide you. So tomorrow I have class. Tomorrow I will finish the Clayton's form, and I will introduce the higher order ordinary differential equation, second order. The elementary things I will tell, and then I will provide you. Yeah, this weekend I will provide you the examples, exercise problems, just for
So
practice.
please stop the recording.
Yeah, I have stopped. I think.
Sir, where will you upload the recording and the PPT
Notes.
you
So you have
use?
to click on the stop recording on the right side.
Stop. Acha, here I have to.
No, sir. On the right side there is a stop recording.
Yeah. Yes.
Where you will be uploading the recording of the class.
Okay, so I will upload it in the MS